4.4, number 179. We have the function y equals the ln of x plus 1 over the interval 0 to e minus 1. We're supposed to determine whether the mean value theorem applies to this function on this interval. All right. So let's think about the natural log for a quick moment. Not natural log of x plus 1, just regular natural log. Very briefly here. So it should look something like this. Tapering off pretty quickly, not permanently. It doesn't go towards a horizontal asymptote, but it does taper very heavily. It's a very slow-growing function, which is one of its main properties. We have an x-intercept at 1 here, and we have an asymptote here. So if you look at the curve of a regular natural log with no x plus 1 inside, just natural log of x, it is a smooth curve as long as you're to the right of 0. Okay? So it is continuous and differentiable, both, as long as you are on the curve, as long as you're on its domain. Okay? So when I look at ln of x plus 1, that is simply a left shift 1 unit. So it will appear something like, if I shift left 1 unit, the vertical asymptote shifts left 1 unit, and the x-intercept shifts back 1 unit. So now we're going through the origin here, the exact same shape completely. Okay? As best as I can draw it. So now we have y equals ln of x plus 1. So again, as long as I'm on the domain of this function, right, which the domain here is what? Should be -1 not inclusive, because that's the asymptote, and to infinity. As long as I'm on the domain of this special natural log x plus 1, then the curve is certainly continuous and it's smooth. There's no cusps, there's no asymptotes happening in here, and there's no discontinuities. So therefore, it should be differentiable as well. So all I need to do now is make sure that these values from 0 to e minus 1 are in this interval. But e minus 1, right, we're starting at 0 and going to e minus 1. So 0 to some finite positive value, right, around 1.7 or something. It doesn't really matter that much. Finite positive value is what we're heading towards here to the right. So we're on a 0 and positive interval. Well, a 0 and positive interval is certainly within this domain, because we're starting at -1 and going towards infinity. So therefore, this function does satisfy the conditions of the mean value theorem. It will be continuous ln x plus 1 is continuous on the open interval 0, e minus 1, and is differentiable sorry, I was thinking about differentiable. It's continuous on the closed interval and differentiable on the open interval. It's actually differentiable on the closed as well, but the way the mean value theorem is phrased, all we need is this weaker condition of it being differentiable on the open, even though it's differentiable everywhere on its domain. But it certainly satisfies these conditions because it has these qualities on that interval. So on these two lesser intervals than here, it certainly has these two qualities as well, and therefore mean value theorem applies.